Okay, in this today's session, we are dealing about exploratory data analysis. That is, we can say that it is EDA. Okay, exploratory data analysis means we have a set of data. From that set of data, we have to detect some patterns or anomalies through visualization. That is we called as an exploratory data analysis. So clear? That means we have a set of data. From that set of data, we have to analyze some hidden patterns or anomalies through visualization. For visualization, we are using some graphical structure. From the graphical structure, we have to identify some patterns or anomalies. That is, we generally called as a exploratory data analysis. Okay. There are various steps involved when doing EDA techniques. EDA following are the common EDA steps. First, we have to import the data, then clean the data, process the data, and visualize the data. These are the important steps doing EDA, exploratory data analysis. Okay, we having a set of data. That data set have to be imported to our data frame. That is the first step. Then clean the data. Clean the data means it's contains some missing data or anomalies. Okay, that dirty data can be cleaned and process the data. Some equations are applying and then process the data. Then apply some visualizing techniques that visualize data, that plot the data into some graphical structure. These are the exploratory data analysis steps. Okay, then we have to identify what is the dirty data. It is an important question. It is asked in the previous year question paper also, a short answer question. What is a dirty data? A dirty data means it is a data that is an invalid data. That means any data that takes away from data integrity of the entire data set is considered as a dirty data. Dirty data. That means it is an invalid data, which is a data that is false or incomplete or doesn't conform to the accepted standard. That data can be categorized as a dirty data. It doesn't convey any information. That type of data is called as a dirty data. If our data contain a dirty data, we cannot detect the patterns or identify some hidden patterns or some analyzing techniques. So we want to eliminate this dirty data. That is our steps. Okay. For example, some of the dirty data are data errors such as misspelled data, typing error, duplicate data, erroneously passed data can be fixed systematically when identified. Data that violate business rule may not be easily fixed even if identified. Okay, some of the examples are given. What is the dirty data? Okay, dirty data can due to missing data, which is the data where no values are stored. For example, suppose if our sensor is taking some data is missing. Okay, that is the dirty data. If our data containing missing data, we can't analyze that data in a proper manner. So we want to avoid this dirty data. Okay, in our programming language, dirty data can be identified as a NA. Okay, several identification methods are there. Some cases, if we are using the missing data as a null, NA, 0, -1, or -2, these all are indicating the missing data. But in the case of R programming, we are using NA as a dirty data, or missing value. Okay. So, to identify a missing value in a data, in our programming, we have to use a function is.na function. Is.na function provides tests for missing values. Okay, this is the function in our programming to identify the missing values. Okay, NA means not available data. Okay, here is one example shown here. How is.na function works. Okay, first we have to assign a vector x is equal to C of 1, 2, 3, NA and 4. Here, 4 items are missing. That is 1, 2, 3 are present and NA means is the missing value. Okay, then 4 is there. Okay, we have to identify is there any missing value or not. So that we have to use the function is dot na, then passing that vector x in bracket. So the result is first is false. False means one is there, it is not a missing data. Second, again false, it is not a missing data. Third, again it is false, it is not a missing data. And fourth, resulting is true. That means fourth value is missing. Okay, is dot na function is used to identify whether a missing data is present in our data set. Okay, clear? Is dot na is the function for identifying missing data in our data set. It is an example. Okay, next, suppose if you want to find the mean of these numbers, if any na value is present in our data, we can't find the mean value. Okay, in the previous example we can see that there is one missing value, that is third item is missing. Suppose if we want to find mean of x, answer is na, because there is a missing item present in our data set. So our answer is na. If you find a correct answer, we want to remove that missing data from our data set. For removing a missing data, we can use a function na.rm. Okay, na.rm is removing a missing data value, then calculate the function. Okay, here in this example, mean of, then passing the vector x, then na.rm is equal to true. That means if any missing data is present in our data set, convert it as a true. So then find the answer. Then we can get the answer. If any missing data is found in our data set, we can't find the result. So first we have to remove the missing value, then find the answer. Okay, that is we are using the function checking statement na.rm. Rm is a remove, to remove missing value during function execution. Okay. Okay, when we are using na.rm is equal to true, it remove the missing value during the function execution. Okay, and one more function is available for excluding the missing value, that is explained over the next slide. That is na.exclude function returns the object with incomplete cases removed. That means if any missing value is present in our data, we can include an na.exclude function. That function will remove the missing column or missing row from our data. Okay, you can see that in the example. First, we have to assign a df. Df is a vector variable. As df is equal to data dot frame x equal to 1, 2, 3 and y is equal to 10, 20 and na. That means one value is missing there. In the case of y, it is a matrix. That is the two-dimensional array. X is the first array, y is the second array. That is so it is a matrix, two-dimensional array. Okay, the first case x contain 1, 2, 3 value and second y contain 10, 20 and third value is missing. Okay, when you are displaying the df array, it look like this: 1, 10, 2, 10, 3 na. That means in the third row there is a missing value. So if you are using an exclude function, this exclude function will remove the missing row from that data. Okay, that means in the example we can see that df1 equal to na dot exclude, then passing our df, that is passing our df array. Okay, what happened is here, this na dot exclude function remove the completely the third row. That is third row is a 3 na will be removed. So the result will be 110, 210. That means na dot exclude function completely remove the missing rows from our data set. Is it clear? Okay. Dirty data means an unwanted data or a missing value data in our data set. Okay, if you want to process a data, we want to remove that missing values from our data. Okay, one method is explained over here. One method is the na.rm is set to true. Then it remove the missing value. Then execute the function. Another method is na.exclude function. What happened is in this function, na.exclude function entirely remove the missing value row from the data set. Okay, this is about a dirty data. Next is another question is visualizing a single variable. It is another question in the examination. It is also asking the previous year question paper. How to visualize a single variable? To visualizing means means a graphical structure. To visualize a single variable, we can use some of the functions in our programming. These functions are listed in the given table. Okay, and these functions are: first is a plot data, second bar plot, third dot chart, fourth histogram, fifth plot with density, then stum data, and then red data. These are the major functions in our programming for visualizing a single variable. Okay, instead of visualizing a single variable, and these functions also can be used to analyze a more multiple variable also. Okay, commonly this is used for analyzing a single variable. Okay, the definition for each one will be explained in the later slides. First one is plot of plot data. That is, plot data is we can call as a scatter plot. Okay, the basic function for plotting is scatter plot is the plot function. In plot function, we have to pass two parameters, x comma y, and x and y are the numeric vectors denoting the xy points. Okay, you can see in the example diagram, some dots are plotted. Okay, that is a scatter plot. Just using a plot function and passing our vectors there, and this point will plot the points in our graph. This is the simple scatter plot. That is the first case, plot xy. First one in the table, plot xy. Next is a bar plot. Okay, bar plot. In a bar plot, data is represented in the form of rectangular bars, and the length of the bar is proportional to the value of the variable or column in the data set. Okay, now similarly, the bar plots looks like a bar structure, rectangular bar structure. Okay, we can display the bar in vertical or also horizontal. Both horizontal as well as vertical chart are possible, and it depends upon the parameter horizon. That means in the examples we can see that using a function bar plot, we can plot a bar plot. Here the air quality of ozone layers are plotted over there, and in the bracket we can see that the parameter horizon is set to true. Okay, if we set horizon is set to true, we can give we get a horizontal bar plot. If horizon is set false, we get a vertical bar plot. Okay, for plotting a bar plot, we use the function bar plot and passing the parameter over there. Okay, in the example we can see that, and the diagram is there. Here we can get a horizontal bar plot, because in the parameter horizon we can set the value as true. If we set the value as false, we can get a vertical chart. Okay, vertical bar plot. Clear? Okay, a second visualizing a single variable technique is a bar plot. In bar plot, representing our data in a rectangular bar forms, and it can be represented in both vertical or horizontal format. The function used are bar plot. In that we are passing some parameters there, and in the parameters, one parameter is horizon. If we set the horizon is true, we can get a horizontal bar. If we set the horizon is false, we can get a vertical bar. Okay, clear? Next is the dot plot. Okay, dot plot. To create a dot plot, we can use the function dot chart. In bracket, passing the numeric vector x and labels. Okay, labels means labels of each point can be passed over there. Okay, to create a dot plot, we can use the function dot chart. Okay, the example we can see that a simple dot chart. Okay, we are passing a car data, miles per gallon data over there. From that, we get a simple dot plot. Okay, look at the dot plot here. Okay, this is a car data. Car data is passed in a dot chart function. We get a dot chart like this. Okay, simple dot chart. No need to go for a details thing. Just what is a dot plot, what is the function there, and just one example. That is over dot plot. Next is a histogram and density plot. Okay, histogram, create a histogram with the function hist of x, where x is a numeric vector of values to be plotted. For a simple histogram, we can just use the function hist of, then passing the vector. If you are using more frequencies in the histogram, then we can set the parameter frequency equal to false, plot probability densities instead of frequencies. Okay, if you want to list more parameters there, then we can set frequencies over there. It is an optional parameter. Simply we can use the function hist of x. For example, same car data can be passed over the function hist of empty car, dollar symbol, mpg means miles per gallon. One column is passed over there and drawing the histogram of that miles per gallon of our car data. Here we are passing the car data in histogram function. The result will be like this. This is a histogram of car data. Car data is miles per gallon. Only one field is passed over there, the miles per gallon, and we get a histogram like this. And how it is different from density plot. Okay, histogram and density plot. Density plots are usually much more effective way to view the distribution of a variable. Okay, here we can see the distribution of a variable. Okay, to create a density plot, first we have to convert our numeric x vector to a density. That is here we can shown in the example, plot of density of x. But density of x means we are converting the numeric x vector to a density value. Then we can pass that data to a plot function. Okay, example we can see that d is equal to density of empty car, dollar symbol, mpg. mpg means miles per gallon, and the miles per gallon data is converted to a density value, and this density data is passed to a plot function. So the result will be like this. It is a graph. It is a curve-like graph. We get a curve-like graph instead of histogram. Okay. In histogram, we get a vertical bars over there. Here we can give the distribution of miles per gallon values. Okay, clear? Histogram and density plot. Okay, in histogram, we use the function hist. In density plot, what we are doing? In the plot function, we have to pass the density of data over there. Okay, next is the stem and leaf plot. Okay, it's just stem and leaf plot is a table. Okay, this table containing, we have to split the numeric value into two. First split is called as, first digit is called as stem and last digit is called as leaf. It is a just like a table representation. Stem and leaf plot is a table representation. Our numeric value can be split into stem and leaf. Stem means first digit and leaf means last digit. And the next one is the reg plot. Reg is not actually a separate plot. It's not a separate plot. What we have to doing in reg plot is that it just illuminate our original graphical plot. That is, it is a one-dimensional display that you can add to our existing plot to illuminate information that is sometimes lost in other type of graphs. That means suppose if you are drawing using scatter plot, some informations are missing over there. We can add some additional information there. We can use rug plot. Additional one-dimensional one-dimensional information can be added to existing plot. We can use rug. Rug is not a separate plot. That is, you remind, rug is not a separate plot. We can add some additional features in our existing plot. We can use rug plot. These are the all plotting operations. That means visualizing a single variables. These all are the functions. Once again, okay, here we can see that the functions over there. Plot is a scatter plot. Okay, in the example we can see that how we can plot a scatter plot. Next is the bar plot. Okay, bar plot we can plot both vertical and horizontal bar. And in dot plot we are using the function dot chart function. And histogram simply in histogram we are using the function histof, passing the data. In density plot we are passing the density of data in plot function. And stem and rug, in stem the numerical data is split into two parts. First half is called as stem, first digit is called stem and second digit is called as leaf. And last one is the rug of data. Rug is not a plot, not an additional plot. It adds some features to our existing plot. It is a rug of data. Is it clear, everybody? Okay, some additional plot. Box and whisker plot. This is another short answer question. This is asked in the previous year question paper also. Some additional plotting operations. Box and whisker plot. Okay, box and whisker plot show the distribution of continuous variable for each value of a discrete variable. That means, okay, suppose if I have a set of data, we have to divide the set of data into three quadriles. Three quadriles means minimum, maximum, medium, and first quadrille and third quadrille in the data set. From the data set, and we can draw a box plot over there. Okay, it is also useful in comparing the distribution of data across data set by drawing box plot for each of them. For each quadrille, we have to plot a box plot. To draw a box plot, we have to use the function box plot function. Okay, the basic syntax is over here. In box plot, we have to pass these parameters x, comma data, comma notch, comma var width, comma names, comma main. What are these parameters are? First x. X is a vector or some formula. And data means it is a data frame. That means our data set. And now it is a logical value. And variable width, it is again a logical value. It set as drew to draw the width of the box, to specify the width of the box proportionate to the sample size. That is, we are indicating in the variable width. And name are the group of labels which will be printed under each block. For each blocks, we have to specify a name. Then we can give the parameter in the name list. Main is used to give the title to the graph. These are the parameters in the box plot function. Okay, for the box plot function, first we have to divide the data into three quadriles. Min, max, median is one quadrille, then first quadrille and third quadrille. And for these three quadriles, we have to plot a box plot. Okay, for this box plot, we can use the function box plot. Then inside with some parameters over there, and these are explained in this slide. An example is over here. Same car data. This car data can be plot using box plot. Here we can get three boxes over here. Three boxes means three quartiles. From the three quartiles, three boxes are plotted over here. These are some additional plot apart from the explained above. Box and whisker plot is an important question. It is asked in the previous year question as short answer question. Box and whisker plot. Similarly, another plot, hex bin plot for large data set. Okay. Scatter plot is also used for analyzing single variable, also for multiple variables also. but it can be analyzed only small volume, as low volume data can be analyzed in scatter plot. To analyze high volume data, we can use hex bin plot. Okay, to analyze high volume data, we can use hex bin plot. If there are, that means if there are too much data, the structure of the data may become difficult to see in a scatter plot. A hex bin plot combines the idea of scatter plot and histogram. Okay, it combines the idea of scatter plot and histogram. Similar to a scatter plot, a hex bin plot visualizes the data in x-axis and y-axis, and data is placed in hex bins. And the third dimension uses shading to represent the concentration of data in each hex bin. Okay, some areas the data may be more. Okay, that portion becomes a shaded over there. Okay, this is a hex bin plot. Okay, generally a hex bin plot is used to represent a high volume of data. That means a large volume data. It combined the concept of scatter plot and histogram. Okay, like scatter plot having x and y axis, and third one is a hex bin concept. In hex bin concept, we represent a shaded over region, the shaded region that represent a concentrated data. Concentration of data can be represented in hex bin. That is shader region. Okay, clear? Clear, everybody?
Clear ആണ് miss.
Okay, one more thing. Another one is scatter plot matrix. Okay, there is a difference between scatter plot and scatter plot matrix. Okay, scatter plot is a simple scatter plot. It contains only a plotting diagram, one single plot diagram. That is a scatter plot. But in scatter plot matrix, it shows many scatter plot in a matrix form. Okay, a scatter plot matrix shows many scatter plot in a compact side-by-side fashion. That is a scatter plot matrix. The scatter plot matrix therefore can visually represent multiple attributes of a data set to explore their relationship, magnify differences, and disclose hidden patterns. Okay, in simple scatter plot, we can visualize a single variable. Okay, in scatter plot matrix, we can visualize more variables. That means multiple attributes can be visualized in side-by-side fashion. That is in a matrix form. Okay, many small scatter plot diagrams are arranged in side-by-side fashion. Okay, from that we can identify multiple attributes and their relationship, and some hidden patterns can be identified from there. That is a scatter plot matrix. So see the difference. Okay, scatter plot and scatter plot matrix, and this is the sample diagram. Okay, from that we can see that so many scatter plots, simple scatter plot, are arranged in a matrix form. Okay, a single scatter plot only contain one variable visualization. Here, so many variables. It is a example of iris data set. In iris data set, here we can plot 1, 2, 3, 4 attributes. That means sepal length, sepal width, petal length, petal width. 4 attributes can be plotted over a single plot. That is a scatter plot matrix. Clear? Clear?
Clear ആണ് miss.